Greenhouses didn't save the ancient harvest. They didn't exist. And yet, farmers in the ancient Near East grew crops through summers that regularly hit 110 degrees. No electricity, no shade cloth from a big box store, no irrigation timer. Just $3 worth of materials and a design principle that predates modern horticulture by 3,000 years. David Mercer, 58, from Waco, Texas, rebuilt this system last June. He had lost 60% of his tomato crop the previous summer to heat stress. After one season using what he now calls the biblical shade method, crop loss dropped to under 8%. Same soil, same seeds, same brutal Texas summer. The only thing that changed was what was above the plant. At minute 420, I'll show you the exact installation. At minute 630, you'll see the three-tier system that makes this work at the biological level. But first, you need to understand why your plants aren't burning from heat. They're burning from exposure. Isaiah 4:6. It will be a shelter and shade from the heat of the day. Most people read that as poetry, as comfort language. It isn't. It's a design specification. The ancient Hebrew word used here, sukkah, refers to a physical overhead structure, a woven covering, something built with intention, placed at a calculated height, angled to intercept direct radiation before it reaches what lives beneath. This was not metaphor. This was method. The people who wrote this verse lived in a climate where midday soil surface temperatures exceeded 140 degrees. They understood something modern gardeners have completely forgotten, that the most destructive force in summer is not drought. It is direct radiant exposure. Psalm 121:6 confirms it. The sun will not harm you by day. Not a promise, a result. A result achieved through deliberate physical design. When a leaf surface hits 95 degrees, the stomata, the microscopic pores that regulate gas exchange and water movement, shut completely. Photosynthesis stops, growth stops. The plant enters thermal shutdown, not because the soil is dry, because the leaf temperature crossed a biological threshold. The ancients didn't have that vocabulary, but they observed the outcome. They watched crops fail under open sky and recover under cover. They built accordingly. What Scripture describes as shelter, plant physiology describes as stomatal protection. Same mechanism, different language. The $3 system you'll see at minute 420 is built on exactly this principle, intercepting radiant load before it reaches the leaf surface, dropping canopy temperature by 15 to 20 degrees, keeping those stomata open through the hottest hours of the day. That's not gardening folklore. That's thermal biology written into a 3,000-year-old text. University of California, Davis, 2019, controlled shade trial on field tomatoes. Shade cloth at 30% density reduced leaf surface temperature by 12 to 18 degrees during peak afternoon hours. Marketable yield increased 23% compared to full sun control plots. Same irrigation, same fertilizer input. The only variable was overhead shade. That number, 23%, came from blocking light, not adding water. The University of Arizona Cooperative Extension measured evaporation rates across a single day. At 6 a.m., evaporation from exposed soil runs at baseline. By 2 p.m., that rate has climbed 300%. Water applied at midday to unshaded soil evaporates before root uptake can occur. The plant receives almost nothing. Modern gardeners water harder. The biblical system shades smarter. Here is the physical mechanism. Direct sunlight carries radiant heat load, thermal energy transferred through electromagnetic waves, independent of air temperature. Air temperature may read 95 degrees. Leaf surface temperature under direct radiation reads 115 to 125 degrees. That 20 to 30 degree gap is the kill zone. That is where stomata close. That is where photosynthesis collapses. A 30% shade cloth, or its ancient equivalent, a woven palm frond lattice, does not block growth light. It filters radiant load. Photosynthetically active radiation still passes through. The plant continues to feed, but the thermal spike is eliminated. Archaeological record supports this at scale. FAO documentation of ancient Near Eastern agriculture confirms the use of overhead palm frond shade structures in Mesopotamian gardens as early as 3000 BCE. These were not decorative. They were positioned specifically over high-value crops during the dry summer months. Height, angle, and density were adjusted by season. Farmers 3,000 years ago were engineering microclimates. They had no thermometers, but they had observation. And what they observed consistently across generations was that crops placed under filtered overhead cover survived summers that killed everything grown in open ground. The science explains why. The archaeology confirms how long it has worked. At minute 420, you'll build the same structure for $3. Before you build anything, do this test right now. Go outside, walk to your garden. Hold a standard cooking thermometer 1 inch above your tallest plant's leaf surface. Wait 90 seconds, read the number. If it's before 2 p.m., and that number is already above 95 degrees, your plants are in shutdown. Right now, today, not wilting yet, not visibly stressed, but biologically stopped. That number tells you everything. Second test. Push your finger 1 inch into the soil directly beneath an unshaded plant. Then walk 3 feet to a shaded patch, under a tree, beside a fence. Push your finger 1 inch into that soil. Feel the difference. That temperature gap is what the biblical shade system creates artificially, over your crops on demand. Now build it. Materials: 4 bamboo stakes, 6 feet tall, 1 piece of burlap or 30% shade cloth, cut to cover your bed, 4 lengths of twine or garden wire. Total cost: $280 to $340, depending on your source. Hardware store, garden center, or farm supply. Nothing specialty, nothing technical. Step 1. Drive 1 stake at each corner of your bed. Push each stake 8 inches into the ground. Lean the 2 west-facing stakes, the ones that will face afternoon sun, outward at a 15-degree angle. This creates a slight westward tilt to the canopy. It intercepts low-angle afternoon radiation more effectively than a flat horizontal cover. Step 2. Stretch your burlap or shade cloth across the top of the 4 stakes. The cover should sit 18 to 24 inches above the tallest point of your plants, not resting on the foliage. Elevated. Air must move beneath it. That air gap is part of the mechanism. Step 3. Secure the cloth to each stake with twine. Pull it taut but not rigid. Slight sag is acceptable. Leave the north and south ends open. Airflow must not be blocked. Heat trapped beneath the cover is worse than no cover at all. That's the installation. 20 minutes. No tools beyond a hammer for the stakes. Here is what to expect. Within 24 hours, leaf curl from heat stress begins to reverse. Newer growth stops drooping by late afternoon. The plant is no longer entering shutdown during peak hours. Within 7 days, new lateral growth appears. Flower drop slows or stops entirely. Plants that had stalled in heat begin vertical movement again. Within 30 days, measurable yield difference. Fruit set increases. Blossom retention improves. The biological system that heat had suppressed is fully operational again. The structure costs $3. The yield recovery is not small. At minute 8:45, you'll see how this installation connects to the 3-tier system that amplifies everything you just built. The shade structure you just built is tier 2. It is not the complete system. The biblical shade method operates on 3 levels simultaneously. Each tier targets a different layer of the plant's environment. Remove 1 tier and the system underperforms. Run all 3 and the biological result compounds. Tier 1, subsurface. Temperature control. Soil temperature drives root behavior. When unshaded soil surface hits 140 degrees in direct afternoon sun, heat penetrates downward. At 2 inches depth, soil temperature reaches 95 to 105 degrees Celsius. At that range, fine root hair activity slows dramatically. At 110 degrees Celsius soil temperature, root hair function stops. The plant cannot uptake water regardless of how much is present. Apply 3 to 4 inches of organic mulch, straw, wood chip, or dry leaf material directly to the soil surface beneath your shade structure. This single layer insulates the soil. Surface temperature under 4 inches of straw mulch stays below 80 degrees Celsius, even when ambient air exceeds 100 degrees Celsius. Root hair activity continues uninterrupted through peak heat hours. Cost: $0 to $150 depending on material source. Straw from a feed store runs approximately $8 per bale. 1 bale covers 40 to 50 square feet at 4-inch depth. Timeline: Soil temperature stabilizes within 48 hours of mulch application. Root function improvement is measurable within 7 days through visible plant recovery. Tier 2, radiant load interception. This is the shade structure already installed. 30% shade cloth or burlap, 18 to 24 inches above canopy. West-facing stakes angled at 15 degrees, north and south ends open for airflow. The mechanism, filtered overhead cover, removes direct radiant heat load from the leaf surface equation. Leaf temperature drops 12 to 18 degrees Celsius. Stomata remain open. Photosynthesis continues. The plant feeds, grows, and sets fruit through hours that previously caused full biological shutdown. One additional detail. The air gap between the cloth and the plant canopy creates a convective buffer zone. Hot air rising from the soil surface exits laterally through the open north and south ends before it accumulates. The space beneath the cloth stays 8 to 12 quadrishim cooler than open air at the same height. That gap is not incidental, it is the mechanism. Timeline, leaf temperature reduction is immediate upon installation. Stomatal response normalizes within 24 hours. Visible plant recovery begins within 3 to 5 days. Tier 3, soil biology activation. This tier is invisible. It is also the most consequential long-term. Soil microbial activity, bacteria, fungi, and mycorrhizal networks operates within a narrow temperature band. Peak function occurs between 65 and 85 degrees soil temperature. Above 95 degrees, microbial populations decline sharply. Above 110 degrees, large portions of the soil food web go dormant or die. When Tier 1 mulch holds soil temperature below 80 degrees and Tier 2 shade reduces radiant load overhead, the soil biology beneath your plants remains fully operational through summer. Mycorrhizal fungi, the networks that extend root reach by up to 700% and transfer phosphorus directly into root tissue, continue functioning. Nitrogen-fixing bacteria remain active. Decomposition of organic matter continues, releasing slow nutrition into the root zone. Without temperature control at both surface and subsurface levels, this biological engine shuts down in midsummer. The plant becomes isolated. Roots unable to access the microbial partnerships that define healthy soil function. With all 3 tiers running, the plant operates in a protected microclimate. Soil biology active, roots feeding, stomata open, photosynthesis uninterrupted. 3 materials, 3 layers, 1 coherent system. The ancients did not have the vocabulary for mycorrhizal networks or stomatal aperture, but they observed what happened to crops grown under layered cover versus crops grown in open ground. They built the system that produced consistent results. Generation after generation, the science arrived thousands of years later. The method was already there. The most damaging thing you can do to a heat-stressed plant is water it at 2 p.m. Most gardeners do exactly this. The logic feels correct. Plant looks wilted. Plant needs water. Apply water. But the logic is wrong and the research is unambiguous. University of Arizona Extension measured evaporation rates from exposed soil across a full summer day. At 6 a.m., evaporation loss from the soil surface runs at baseline. By 2 p.m., that rate has increased 300%. Water applied to unshaded, unprotected soil at peak heat evaporates within minutes. Root uptake receives almost nothing. The wilting continues. The gardener waters again. The cycle repeats. But evaporation is not the primary problem. When cold water contacts a leaf surface sitting at 115 to 125 degrees Celsius, the rapid temperature differential causes immediate cellular stress. Stomata that were already closed from heat now experience thermal shock. In tomatoes and peppers, repeated midday watering on heat-stressed foliage has been directly correlated with blossom end rot, fruit cracking, and accelerated leaf senescence. The plant is not being helped, it is being disrupted twice, once by heat, once by the intervention. There is a deeper structural consequence. Consistent midday watering, even when delivered at the root zone, trains root architecture to remain shallow. Roots follow moisture. When water is applied at the surface repeatedly during peak hours, fine roots migrate upward toward that surface moisture. They move into the zone of highest heat, into the zone of fastest evaporation, into the zone of greatest biological stress. A plant with shallow roots trained by midday watering is more vulnerable to heat, not less. Each watering event that feels like rescue is quietly restructuring the root system toward failure. Ecclesiastes 11:4. Whoever watches the wind will not plant. Whoever looks at the clouds will not harvest. The verse addresses timing. Waiting for perfect conditions produces nothing. But the underlying principle is precise observation, driving correct action at the correct moment. The ancient farmer watered at dawn, not from ritual, from observation. Morning water absorbs before evaporation peaks. Root uptake is maximized. Foliage stays dry through the heat hours. Fungal pressure drops. Water at 6 a.m., not 2 p.m. If the ground beneath your shade structure and mulch is already retaining moisture, which it will within 7 days of the 3-tier system running, you may find that daily watering becomes unnecessary. Every other day, sometimes every third day, the system holds what the soil receives. That is not water conservation as a goal. It is water conservation as a consequence of building the system correctly. A basic hobby greenhouse. Aluminum frame, polycarbonate panels 6 by 8 feet. Retail price, $300 to $600. Assembly time, 4 to 6 hours minimum. Lifespan, 7 to 10 years with maintenance. Requires anchoring, ventilation management, and active temperature monitoring in summer. In many climates, a sealed greenhouse in July becomes a heat trap. Internal temperatures exceed 130 degrees without mechanical ventilation. You add a fan, that's another $40 to $80. You add a thermometer and vent opener, another $25 to $60. The system designed to protect your crops from heat now requires active management to prevent it from cooking them instead. The biblical shade system. 4 bamboo stakes, 1 or 20, 1 by 10-foot piece of burlap, onpars 50, twine 0.30, total 3 points or assembly time 20 minutes. No tools beyond a hammer, no anchoring system, no ventilation calculation, no electricity. It does not trap heat. By design, it cannot. The open north and south ends, the elevated air gap, the natural breathability of burlap or woven cloth. These are not compromises. They are the mechanism. Airflow is built into the structure. Durability framed correctly. 1 burlap panel lasts a full growing season. At the end of the season, it composts directly into the bed. 0 waste, 0 disposal cost. Next season, $150 for a new panel. Or reuse the bamboo stakes, which last 3 to 5 seasons, and spend $150 total. Over 5 years. Greenhouse, $300 to $600 initial, plus $100 to $200 in fans, vents, and replacement panels. Conservative total, $500 to $800. Biblical shade system over the same 5 years, $15 to $20 in burlap. Bamboo stakes purchased once. The greenhouse offers advantages the shade system does not. Season extension into frost months, protection from wind and heavy rain, enclosed pest management. These are real. If those functions are what you need, the greenhouse is the correct tool. But if the problem is summer heat stress, if the problem is crop burn between June and September, the greenhouse is $600 worth of infrastructure solving a $3 problem. The ancient system is not primitive. It is precisely scoped. It solves one problem completely with minimal material, 0 ongoing cost, and no mechanical dependency. That precision is not a limitation. It is the design. Proverbs 27:18. He who tends a fig tree will eat its fruit. Not he who owns it, not he who planted it, he who tends it. Tending is not watering harder. It is not spending more. It is not adding complexity to a system that was already complete thousands of years ago. Tending is observation, correct diagnosis, precise intervention at the right moment with the right material. A woven cover, 4 stakes, 3 inches of mulch, positioned correctly above a living root system that simply needs its temperature managed. That is the entire system. That is what kept ancient crops alive through summers that modern gardeners consider unworkable. Not technology, not infrastructure, not investment. Observation, built into structure. The knowledge was never lost. It was written down. It was practiced continuously across cultures and centuries. It was abandoned only recently, within the last 50 years, when the default answer to every agricultural problem became a product purchase. The $3 shade system does not ask you to believe anything. It asks you to build it, test it, and read the result with a thermometer. The result will speak for itself within 24 hours. If this method is new to you, drop a comment below with your state and what you're growing. I'll tell you exactly how to angle the structure for your sun exposure and your crop height. If someone you know is losing plants to summer heat right now, share this video. The information is simple. The build takes 20 minutes. The difference in yield is not small. Subscribe if you want the rest of this series. Next video covers the biblical root training method, a subsurface clay pot system used in ancient Israel that reduces water use by 60% while doubling root depth. That system also costs under $5.